Okay, so remember what I said in the previous video where I was solving problems from chapter 14 is that you should all try to do question 1 on your own. So for chapter 15, you see there are problems, how many? 8 statements. So once again, go through them. Try to figure out if they are true, false, or uncertain, and then try to briefly explain why. Okay, so I'm going to start solving problems from number 2. So let's do that. So in number 2, we have 2 friends. We have Lucy and we have Adam. Lucy is going to be earning 70,000 every year. Adam will earn 45,000 every year. They expect a 2% increment. So their salaries will be going up by 2% every year for 3 years. Same for Adam, 2% rise for 3 years. What else? Real interest is effectively 0%. That makes things easy. And tax is 30%. Okay. Lucy does not have any non-human wealth. Okay. Adam has non-human wealth. So let's write it down here. Non-human wealth. Adam has 50,000. Okay, that seems simple enough. Question 1, we have to calculate the non-human wealth and total wealth of the 2 friends over the next 3 years. Okay, so what I want you all to take a very close look at how question 2a is phrased. Specifically look at what's inside the bracket, okay? So as you noticed, this increment is only for 3 years, And inside the bracket in the question, it says that assume there is uncertainty about the future beyond these 3 years. That's important. And that's something you guys should keep in mind as well. As we've talked about during other videos in chapter 14 and 15, is that the further away we are trying to impose our expectations on, the higher the chances that our expectations are going to be wrong. Trying to expect economic conditions 5, 10, 20 years into the future or even longer, it's very difficult and will almost always be wrong. And this question is a proof where they are only going up to 3 years and not beyond that, because it's difficult to anticipate what might be happening. Okay, so let's try and solve this problem. And let's try solving the human wealth for Lucy. Okay, so Lucy is going to be earning 70,000, but there is a tax of 30%. So her take-home income, her disposable income, will be 70% of 70,000. That's 49,000 for the first year. Next year, 49,000, but with an increment. And next year, same 49,000, but with the increment rate. Easy enough. And then you guys can use your calculators to figure out how much this is. Human wealth for Adam. So he's going to be earning 45,000. After paying tax, he will have 31,500 left. And then of course, the increments, and then you calculate how much you get. So this is the human wealth. We have to calculate the total wealth as well. Now total wealth, as if you guys remember, is human wealth plus non-human wealth. Lucy does not have any non-human wealth, so therefore total wealth for Lucy is her human wealth, basically. So however much you guys get here. And for Adam, total wealth for Adam will be whatever you get here. So human wealth for Adam plus 50,000, the bond that he has. And then you guys calculate how much that will be. So that was part A, simple enough. Let's move on to part B. Let's read the question. If both friends, excuse me, wanted to maintain a constant consumption level over this period, what would their consumption level be? Okay, so we are looking at a 3-year period, right? So what, and if they want to, excuse me, if they want to maintain a constant consumption, all you would do is take their take their total wealth, and let me write this down actually. So consumption per year should be their total wealth over the 3-year period divided by 3. So for example, if what's this guy's Adam's total wealth is let's say 300,000, then every year he can consume 300,000 divided by 3, that's 100,000. That's constant consumption, simple enough. Oh, and of course we don't know what this figure is, we haven't calculated it. It's part B. So let's take a look at part C. How would an increase in tax, okay, so tax used to be 30%, then it's going to go up to 40%. How would this affect the relative wealth position of Lucy and Adam? How would it affect their permanent consumption level? Once again, this is very simple. We can do the calculation, and the only thing that will be different when you do the calculation is like this figure 49,000, this will change. This figure 31,500, this will change. This will change, and I'm sure you guys can figure that out. But even without doing the calculation, let's try to think about this theoretically. Okay, so what will happen to human wealth if tax goes up? We're paying more tax, so our disposable income is falling, so human wealth will fall. As a result, what will happen to our consumption? If our disposable income falls, consumption falls. If it's not immediately obvious to you guys, then just write down the consumption function. This is what we had in 207. And if this, if this is falling, then of course this will also fall. So pretty straightforward. What else is there? That's about it really. But what I will urge you guys to do the calculation. So we know that human wealth will be falling, figure out by how much. We know consumption will be falling, figure out how much. Let's move on to part D. Suppose Lucy works for a firm whose stock market value goes up. Okay. Lucy, along with all her colleagues, sees salary increase by 10% instead of 2% over the next 3 years. How does that change Lucy's human wealth? Oh, that's once again simple enough. So human wealth of Lucy is how much? So tax has gone up. So she's earning 70,000, but she's paying 40% tax. So she has 60% of her income left. And on that, she's going to be now experiencing a 10% increment square here. And then you guys just use your calculator to figure out what the answer is. And of course, you know that human wealth for Lucy will go up from what it used to be because her increments are higher now. although tax has also gone up. So I'm not really sure what will happen. You guys figure it out with your calculators. And finally, part E, if the increase in salary were to be made permanent, how would that affect Lucy's consumption level? Okay, that's, well, consumption will go up as well, of course. So, I mean, since human wealth is going up, that's disposable income. As a result, consumption must also go up. But as I said, do the calculation and find out the new consumption. Or actually, consumption might go down as well if human wealth is going down. As I said, it's tough to say without a calculator. You guys will figure it out. So that was number 2. Question 2. Let's try and do question 3. Hopefully, it will be a bit more challenging. Okay, so a private hospital wants to buy an equipment. Equipment cost is $1 million. This equipment will bring in extra net profit, not total, remember, extra net profit worth 150,000 every year. Interest, real interest is 8%, and depreciation is how much? 10%. So first question is, should the hospital make this transaction? So of course what we do is we have to calculate the present value, right, of expected future profit, which will be equal to, you will be earning 150 every year, 150,000, divided by 0.08 plus 0.10, and that is going to give us 18, so something like, I think, I don't have a calculator, excuse me, something around 850,000. You guys figure it out. So what you see is that you will have to pay 1 million, but the expected value, the expected present value of all the income that you will be earning is 850, which is less, right? So you will be spending more than you will be earning. So therefore, do not buy the equipment. Easy enough. Let's take a look at part B. Okay, so interest rate goes down. Interest rate used to be 8%, then it went down to 5%. Okay, so let's do this calculation again. Expected value of all profits, 150 divided by, now this is 0.0 plus 10. So this gives us exactly, this is a dollar here, 1 million. Okay, so what we see now is that the cost is 1 million and the net present value is also 1 million. In this case, you are sort of indifferent. You can make the investment, you may not make the investment. Either way, you don't make a profit or a loss. So you're sort of indifferent. You can buy the equipment if you want to, that's fine. So over here, it depends on your interpretation. You may say that since this is a private hospital, they're still not making a profit. So without making a profit, it doesn't make sense for them to make this investment. That is correct. Or you may go and say that although they're not making a profit, they're not making a loss either. But at least what will happen is that this will see a rise in their business. Maybe they'll be able to treat more clients. Maybe they'll be able to diagnose different diseases and sicknesses and all that. And so as a result, even though there is no profit, they should buy the equipment. It really depends on how you want to interpret the scenario, and both answers are correct. Okay, Let's try and do number 4. This is the last problem that I will be solving. Okay, so at age 22, you have finished college and you will be offered your first job, the salary of 40,000 per year. Okay. This will remain constant, okay, so no increments. However, you may also go to a professional school, so you may go back to school, and this is for 2 years. So you'll be in school until you're 24, and when you come out 2 years later, your salary will be 10% higher, so it will be 44,000. Okay. What else is there? I mean, this will remain constant. Tax is 40%. Okay. So part A. Real interest is 0. Okay, that's good. Simplifies things. You expect to work until you're 60. You want to work until 60, which means that if you start working immediately, you will work for 58 years. And if you go to school and then start working, you will work for, no, not 58, sorry, 38 years. And if you go to school, then you will work for 36 years. Okay. We have to find out what is the maximum you should be willing to pay in tuition to attend. Okay. This is an interesting, simple problem, but interesting. So you have these two options. Suppose you've graduated from BRAC University. You're 22 years old. You can start working immediately for a salary of 40,000. Or what you can do is you can go back to school, get a master's degree. That will take 2 years. And when you start working, you will be earning 44,000. Okay. And you want to retire at 60. So the question is whether you should go to school or not for that 2 years. And for that, what will have to happen is that this 2 years that you are sacrificing, this 2 years, you are not earning anything. In fact, what's going to happen is that you will be paying the school money, your tuition fees. So the loss that you are experiencing, the loss of salary plus the tuition fee, the question what we have to figure out is whether that amount is more or less than this 4,000 extra that you will be earning from going to school. Okay, so for that, let's just figure out the human wealth. So if you start working immediately, so let's call it human wealth of working immediately, what you will have is taxes 40%. So you'll be earning 40,000, but you will be paying 40% tax. This is your disposable income. And notice the question says that this will remain constant in real terms. So we do not need to discount it or increment it or anything. We just multiply it with 38 because that's how long you will be working, and you get a figure. Human wealth, if you go back to school and then work 2 years later, you will be earning 44,000. This is your disposable income. And now you will be working for 36 years because you've been in school for 2. And then you will find another figure, right? So what you want to do now is take your human wealth from going to school, and from that subtract the human wealth of working immediately. You've calculated those two figures here and here, and you get a number. Suppose you get 100, okay? 100. What that means is that if tuition for school is more than 100, don't go to school. And the opposite is true. If tuition is less than 100, go to school. Why? Because what we have calculated here is the extra income you will be earning in your lifetime by going to school. And if that extra income is not more than the cost of going to school, then it doesn't make sense for you to go to school. But of course, if it's more, then you should go to school. So intuitively, very easy to figure out. I'm just showing you guys mathematically how to solve them. That's part A. Let's take a look at part B. What is your answer to part A? If you expect to pay 30%. If you expect to pay 30% in tax, then all that will change is over here. Instead of 0.6, you will write 0.7, 0.6, you write 0.7. That's it. And then you will find a new value here. You will find a new value here. And then you do your analysis once again. Okay. So that's it. That's all the problems. I've solved how many? 2, 3, 4. So I've solved 3 problems for you guys. Here's what I am going to ask you all to do. Okay. Try and solve number 5, number 6, number 7. Okay. Keep in mind, these are different, not only different, but these are slightly tricky. Okay. So give it a go, try to solve them. If you cannot solve them, don't worry. Okay, it's perfectly fine. These are slightly tricky, slightly difficult problems to solve. If you cannot, there is nothing wrong with it. But if you can, there you will find some interesting economic insights in these problems. In fact, these problems use something called a 3-period lifetime model. It's a very common model used in economics, where we assume that a person's lifetime is separated into 3 periods. One where you're young, and then you're in your middle age, and then you're old. So usually what we do, the assumptions we make is over here, you have 0 income. You're basically receiving education or training, and you're not earning anything. But since you don't have any income, you have to borrow money. A lot of people borrow money for their education and all that. At middle age, you are earning income. However, you are earning, but you're also doing 2 things. You are paying back how much you have borrowed when you were young. And at the same time, you are saving for your old age. And then, of course, there is a third branch, which is you are spending. So you're doing these 3 things. And at old age, once again, you have 0 income because you're not working anymore, but you don't have to borrow anymore because you have savings. This has come down. So the more you have been able to save, the more you will be able to consume in old age. So this is a very common model that we use in economics. And this is a overlapping generations model. So like not everyone in the economy is at the same period in their life. So while this is going on, while you're young, there are other people who are middle-aged and who are old. Then during your middle age, there are young people and old people. So it all overlaps, and overall, the economic intuition that we get from this is quite interesting. We are not going to go into too much details in question 5, 6, and 7. There's no model. Everything is just explained to you guys, but it's still a very interesting three problems to take a look at. So do try to solve them. Okay. That's it for chapter 15. Next week, we will start chapter 16, which is the final chapter before the first quiz. So good luck with that.